This is the first short video in a series to help you understand how to get the best from black duck scanning. There are 6 ways that open source can be included in projects. The first and most common method is to use a package manager to define dependencies. Another common method is to use side installed packages. This can be components or archives which are added to your project, but note that they can also be within the dependency tree. The original way of copying open source was to use the source hierarchy and copy that into your project. Another option is to copy functions or methods from within open source packages into your custom code. Linking open source is another option, using a compiler or linker to add the libraries. And finally, putting your applications in containers can add additional open source beneath in the base image and above in the layers of your application. Black Duck has the most comprehensive techniques for identifying open source using Synopsys Detect. The first thing that Synopsys Detect will do is to call the package manager to identify the dependencies. It will then perform a signature analysis, which essentially is a folder scan to identify files of any type that have been copied from open source origins. An option is to then use snippet analysis, looking only at source files to identify exact files which have been copied or partial matches. Another option is to use the binary scan to present specific binary files or archives to the binary scanner to find linked open source or libraries. And a Docker scan is also available to look at the base image and identify open source in the layers. So let's start with the package manager. This is called detector mode. In detector mode, the Synopsys Detect tool supports multiple package managers, and here's a partial list. It identifies if it should use the package manager by looking for files, and here is a list of the files for each package manager. If it sees one of these files in the invocation folder, then it will call the required package manager. Let's have a look at this in action. So here is a GitHub project, and it has a hierarchy including a pom.xml file. If I download this onto my local machine using a clone and run detect, the first thing it will do is see the pom.xml and try and call Maven. So before I run detect, I must ask the question, is Maven installed? Notice that some projects have wrapped package managers, for example, Gradle W or Maven W, which mean that I don't have to have the package manager installed, and detect will use that if it's available. So if I perform the scan using detect and it sees pom.xml and calls Maven successfully, I will get a hierarchy, a dependency tree, as you can see here. If you don't have Maven installed and you want to do a partial scan, there is a build list mode available for multiple package managers. And by specifying this, it will just look at the top level dependencies because it cannot resolve the lower ones. This is a partial scan and should only be considered when you aren't able to perform a full scan. Another consideration is that detect is only going to look in the invocation folder for the specific files for package managers. If your package manager files are in a hierarchy lower than the current folder, then you can specify a search depth. In this case, build.gradle is 1 folder deep, and therefore I've set the search depth to 1 so that it will identify that file and then call Gradle in this case. Do not set this number to a very high number because you will identify many subfolders, which can take time, and also include many sub-projects, which are often defined in the top level project, and you will have duplication. If you want to get the best from the dependency scanner, then the first thing is before you start to identify the package managers which are required. The second thing is that with those package managers, check that they are installed. Are they on the path? And if they're not on the path but are installed, you can use options to tell it where it is located. If it's not installed, then you could consider a build list scan, but this only supports some package managers and is a limited dependency analysis. There are some prerequisites for specific package managers. For example, in NPM, you must run npm install, and you might consider also building the project so that we can see all artifacts. There are other options which are package manager specific as well. In pip, you need to specify the requirements.txt, and you can use things like excluding certain dependencies in certain package managers. Please see the documentation for assistance. Moving on, the second type of scan supported by detect is the signature scan. So what this does is it looks at the invocation folder and identifies all of the archives in the entire hierarchy, and which it will expand in memory. And multiple file types are supported for expansion: zip, tar, gzip, jar, war, ear, and many more. Then for every folder, it will create a signature, which essentially is a list of the files and the file sizes. Something that was changed in the Detect version 6.1 is that an additional matching type called individual file matching was turned off. So this previously used to look at specific source files, JavaScript, and binary files, DLL, lib, exe, and so on, and create individual file signature matches. This would allow them to be found outside of folders. This has been turned off because specifically for binary file matching, it can cause false positives. The source file matching was useful for JavaScript, especially client JavaScript, which is often distributed in individual file locations, but snippet matching is a good way of replacing this. Individual file matching might be useful in something called custom signature matching, but this is dealt with elsewhere. There are also two new optional text file searches that can be performed. One is a local license text. Essentially, it looks only at the text files and looks for license text or references, so you can identify that something has been done locally. This is looking at your source, and it's particularly looking for people adding license text to your code, which you may want to know about. They may also be adding other open source, and you can find that by looking for the license text or references. Another option is copyright search, again performed locally. Purpose here is that it allows you to find copyrights added by your developers, but it can also be used again to identify new open source or additional open source. So for signature scanning, the first thing you need to do is to check the size. There's a default limit of 5 gigabytes per scan for the signature scanner. If you have a project bigger than 5 gigabytes, then use excluding technologies to exclude large folders of binaries. If you do truly have large projects, then you can perform more than one scan on subfolders and combine into a single project. Identify if individual file matching is useful. In most cases, this is not true. And consider the additional scans, the local license text and the local copyright text. The next type of scan is snippet analysis. This is optional, so not performed by default. It's actually a part of the signature scan, but it is a second phase. There are 4 combinations of using snippet scan, and they essentially are either looking at the things outside the matched signature folders. What that means is if a folder has been identified in the signature match as open source, then do or do not scan it according to this table. And also looking at changed files. So each time you do a scan, it's storing the file times of the last modification. And if the file is more recent, then it will either scan it or not. And you can see the 4 combinations here. So these are the options that you can use. Notice also that there are 2 output snippet match types that you will get in the tool, and they are full file or exact file and partial, as in lines. Snippet matching looks at the first 2 megabytes of every source file and will ignore beyond 2 megabytes. Here is a list of all of the file extensions which are supported by snippets. Moving on, the next scan type is binary. This is called the binary scan mode. So binary scanning is very straightforward. Assuming you have a license, this requires an additional license. If you do not already have it, then you can actually specify either a single file, which could be a single binary or an archive of binaries for upload, for scanning, or you can use a search technology looking in the invocation folder. So you could say all files of star.zip in a particular folder. The files that are specified for binary scan are uploaded to the server for scanning. They are not looked at by Detect, and they are deleted immediately after the scan on the server so that you don't have any information leakage. The final scan type is Docker. So Docker has 2 modes of operation. You can either specify the image name, in which case a multi-stage process will be performed. It will check that the image is local or download it from your Docker repository. It will then use and download a Docker inspector to see if it can identify the base image. Once it's done that, it will actually extract the base image dependencies if a package manager was used for that. Notice that this process requires you to start a Docker container. Therefore, you must have Docker installed, you must have the ability to start a Docker container, and you should not use this by default from inside a Docker container. It then goes on to extract the file system from the Docker image and perform a signature scan. Alternatively, you can send just the Docker tar archive of the file system, and that would perform a simple signature scan on that. So that's the summary of all the different scan types. Notice that they can all be done in one run, so you can perform binary and signature and package manager and so on, or a single type of scan using control options, or you can perform multiple scans and send them to the same project so the results are collated. Please see the next video so you can understand how to perform scanning.